Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x is equal to 7. Now what I'm first going to do is I'm going to take the log of both sides. So now we're going to have log 5 to the power of x is equal to log 7. So now an important property of logarithms is, let's say we have log a to the power of b. The power property of logarithms states that we can actually move this exponent here, b, into the front of the log, meaning this would equal b log a. So right here we have log 5 to the power of x, and we can actually move our x here into the front of the logarithm. So now this would be equal to x times log 5. And this is equal to log 7. Now, I actually want to isolate x because that's the thing we want to find the value of. So I'm going to divide by log 5 on both sides to get rid of the log on this side and to move it to the right side. So now for our left-hand side, these two cancel out. So we would have x is equal to log 7 is equal to 0.845 approximately. And we're dividing this by log 5, which is approximately equal to 0.699. So now the answer for this, x would approximately equal 1.209. So this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x plus 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 5 to the power of x is equal to 2. Now, because our left-hand side here has all our terms being 5 to the power of x, what I'm going to do is I'm going to factor out 5 to the power of x from our left-hand side. So by doing that, I get 5 to the power of x times 5 to the power of x divided by 5 to the power of x is 1 plus, same thing again, they're the same terms, 1 plus 1 plus 1 plus 1. Now, we want to simplify what's in the parentheses. So 1 plus 1 plus 1 plus 1 plus 1, that's going to be 5. So now we have 5 to the power of x times 5. And remember, this is equal to 2. Now, we want to isolate x, so I'm going to divide both sides by 5. These two cancel out for our left-hand side here. So for our left-hand side, we have 5 to the power of x. Now, this is equal to 2 over 5. Now what I'm going to do is I'm going to take the log of both sides. So now we have log 5 to the power of x is equal to log 2 over 5. Now, an important property of logarithms is that if we have something in the form log a to the power of b, the power property of logarithms states that we can actually move this exponent b to the front of the logarithm. So this would actually equal b times log a. So in this case, we have log 5 to the power of x, and I can actually move this exponent x to the front of the logarithm. So this would equal x times log 5 is equal to log 2 over 5. Now, another property of logarithms is that if we have a log of a fraction, let's say log a over b, this would actually equal the log of the numerator minus the log of the denominator. So log a minus log b. So we can do the same thing to log 2 over 5. So this is going to be x times log 5 is equal to log 2 minus log 5. Now I'm going to divide both sides by log 5. So now we get x is equal to log 2 minus log 5 over log 5. Now, the value of log 2, this is approximately equal to 0.3010. And log 5, is approximately 0.6990. So now if we plug these values in, we get x is equal to 0.301 minus 0.699 over 0.699, and this means that x is equal to negative 0.5694. So this is our answer.